Hi, my name is Jeffery Shivers, and this presentation is going to be about a new tool called Protop, which is a package manager for gRPC and protobufs. So a little background on myself first. I'm a software developer based in Boston, and I've spent the last few years working at a company called Toast, building technology for restaurants. And in the evenings, I study in the engineering management program at Tufts University. Before I was even interested in software, I was composing music, studying and traveling around the world doing artist residencies and weird performances like this. And then I happened to have my first experience in software through a program called Google Summer of Code. If you're not familiar with it, it's basically a program where Google sponsors students to spend their summer working for open source projects. In my case, I had the opportunity to work for the GNU project on a music notation software called LilyPond. So I'm excited to be able to present the next big open source project that I've been working on for a little while now. So this presentation is for you if you use protobufs or gRPC in any way, whether you're an expert in the tools or if you're a novice in the technology. If you collaborate, whether that's on a team, across teams, or just across services in your stack using this technology, and if you're at all intimidated by them. So this isn't necessarily for a seasoned developer in this framework. So if you're brand new, then this might solve some of the technical overhead when you're just getting set up for the first time. So I don't usually like to work on projects that add complexity to other things. I found that sometimes new tools like this can be intimidating. Sometimes it will uh, add to our tool set just to solve some issues. So one of the things that I'm trying to do here is make sure that I'm at least making some of this stuff easier to do and not adding more complexity to the process. So the presentation is going to go a little bit like this. We'll talk about existing development patterns with protobufs, and what that kind of looks like, and then I'll give an introduction to the tool itself, and then a quick demo of a distributed gRPC app, and then we'll end with some key takeaways. So how do we typically develop projects using protobufs? And that's including even non-gRPC projects. So there's a lot of use cases for protobufs outside of gRPC, and how does that kind of look like in our stack? The easiest context for developing protobufs is if you're working with a monolith, because just like any other shared dependency, everything has access to it if it's in the same code base. So while there's obviously trade-offs if you're developing monoliths and you want to trend away from doing this, it happens to be really convenient in the case of protobufs because there's no copying pasting, no figuring out how to distribute them across your system if they're just always there. Most of us are probably working in distributed systems though, so our services are broken up into a few or many different parts of the system, and somehow we need to get the protos, if we're using protobufs, from one service to the next. So the next step, usually what happens is that we put our protos into the code base still of the service that's going to be implementing them. And then that's probably generating some artifacts and sending them into some internal registry like npm or Maven, and in whatever implementation of that, whether it's like Artifactory or Nexus. And then that's how we're getting them into the other services. We're passing them through via the generated code. Slightly better version of that is proto repos, where basically you just break the protos out of your repository, but still, in most cases, today what I see is that services or teams are still creating pipelines where the protos are just immediately being generated into whatever implementations or stubs might be needed, and then those libraries are pushed and out into the other services. So this doesn't quite distribute the protos as much as it distributes the code that's generated by them. What I would like to see is kind of a twist on that. Instead of distributing the code and immediately generating everything that we might need from protos, and maybe even generating some waste if we don't always need everything in every language, would be to just simply distribute the protos themselves. And so it kind of looks like the last pattern, but instead imagining that we just simply have a way of retrieving the protos themselves into all of the code bases that might need them, and then placing responsibility of generating the code onto those implementations. So this leads me to the guiding principles of the tool that I'm talking about today, Protop. So the first point is that I think that protos should at least be able to be small composable things. We already do some composition when we have a single proto repo and we use imports. We also import other stuff from like the Google Common protos pretty frequently. So it would be nice to be able to easily do the same thing within our own system. So if our company has some common proto libraries, to be able to develop them separately from some specific API and be able to pull them in and compose them that way. And the next thing is that I really think that protos should focus on one thing, and that's defining the API or defining the blueprints underneath an API, and that we should strive to keep these separate from their implementation if possible. And that includes generating the code, because that really is the thing that becomes the implementation as soon as it's dropped into a real service. And then finally, to reiterate the last point, again, coming back to the idea that tools should really make things easier, not harder to do. So instead of introducing another new pipeline, a whole framework for throwing around protos and doing a billion different kinds of validations, I wanted to build something that was just extremely simple and just focus on the one thing, which is just distributing protos. So what is Protop exactly then? At its core, it's basically a package manager for protobufs. It follows the typical pattern of any package manager out there. So if you can think of Maven and NPM are pretty direct analogs to this tool. But it's literally a command line tool. So you install it to your machine and you use it with nearly synonymous commands such as init and publish and sync in order to move protos around between projects. And then at the highest level, it's also kind of a pattern for protobuf and gRPC development. So I keep talking about distributing protos and not their implementations. So while this doesn't enforce anything, it doesn't make you do that, it does enable you, and I highly suggest those guiding principles to just distribute the protos and then let the services worry about what happens after that. So this is kind of what a workflow might look like then if you're using this tool. The first thing you would do is start a project by creating a manifest. So you would just say protop init, or you can manually create a protop.json file. And this is just a JSON format with some properties that give us a way to identify the project. And then if it has any dependencies on other proto projects, then you give it a dependency map and you point to them that way. If you're developing protos locally using Protop, you can just use protolink, and this is an analog to publishing to your local Maven repo on your machine, or npm link is where the inspiration for the name actually came, and it really just does that. It creates a symbolic link in your file system, and really nothing more in order to get the protos across your projects. But you can also use Protop publish, which right now is a technically experimental feature, so it's not on the master branch. If you install this from Homebrew, you're not going to get this, but it's something we're working on developing right now. And the alternative to that is to just simply publish the project to a Git repo. This is the easiest way and probably what we're already doing if you have your individual proto repos. So all you need to do is just drop in a manifest, and then technically it's a published proto package. And the last thing you do in order to get your protos into the next project that needs them is you run protop sync. And this basically resolves them in a certain order. So if you say that you want to use the linked projects on your file system, then you add a flag for that. And you can see that it looks something like this here. This little notation with this arrow is basically saying that this is a symbolic link to a project that I'm developing. And it'll also resolve external dependencies, whether it's in GitHub or in a proto registry when that exists. So next, I'm just going to start a quick demo here. So this is a distributed gRPC application. And what that really means is we have two services that are going to use some protos that are being developed in a third repository. So I have a little API here, and this is for a ping pong service. And all it does is it creates a binary stream here. So we have an RPC call called ping pong, and it's going to take a stream of these ping messages and return a stream of pong messages. And so this is what I want to use between my services here. So in order to actually get the protos into this project, I need to give this project a manifest and then link it, because I haven't published it yet, and so I'm just developing these. So in order to start it with that, I'll say proto-p init, and this is going to ask me a few questions, what the organization name is. So I'll say that I'm with proto-p, and for project name, I'm just going to say the project is called ping pong, and then the revision is arbitrary. I don't really care right now, and then that created this manifest for me right here. So this is all I need in order to run the proto-p link command successfully. So I'm going to do that now. And there we go. So this project now should be accessible to my services that want to implement the protos. So now I'm going to go into the Java service that I've started here. This is just a basic Java app that creates a gRPC server, and it doesn't have any services yet, but that's what I'm going to do next. In order to do that, in order to create my implementation, I need to get those protos into this project. So I've set up I'm using Gradle for this, and I set up the build script using the Protop Gradle plugin, which basically just makes it a little bit easier to work with the Protobuf plugin. And I passed in a flag that says that I want to use links on my machine, so I want to check if there's any projects for the dependencies before checking the external registries. And then just going through what I need to do with the setup here, it's pretty minimal. I also need to just add my proto sources from the protop directory so that the protobuf generator can find them. And then I want to make sure that the protobuf generator only does that after protop sync has been run, so that we're not generating anything before everything is pulled into the project. So I'm going to manually create a manifest here. And I don't need all the ID stuff like the name and the organization. I really just need a dependency map, because that's all I'm doing with this. I'm not publishing this anywhere. So the project that I'm going to depend on is the organization/project name, which looks like that. And I do need to give it a valid version, even though I'm not pulling it from an external registry yet. But it would look something like this. So if this project was published on GitHub, if the API protos were published there, I could give it a prefix like GH to say that they're on GitHub. And then I can give it the registry path. So in this case, the protop org is protop-io. And then the project, let's say, is ping pong protos, like that. But it's not even going to really have to check there, because, again, we have the project linked locally. So let's go ahead and try to run protop sync here. And we'll do that using Gradle build, since it's built into that. So I'm just going to, you can see protop sync is running, and it looks like it succeeded. So now I should see a new folder in my file tree here called .protop. And if I follow the tree down, I can see that my API has been pulled into this project. And again, it didn't copy them. This is just a link to my other project. So as I make changes, I'll actively see changes here as well, and I'll be able to leverage them in my service. So I'm going to go and implement the ping pong service now. I'm going to collapse this, and I'm going to create a new class called ping pong service. Okay, and I'm going to have this extend the ping pong service implementation base. And there's just that one RPC that I want to override, and it's this guy right here, ping pong, which is going to take a response observer, and it's going to pass back this stream observer. So I want to override this default stuff here, and I'm going to create a new stream observer. And so every time I receive a ping message from the client, what I want to do is respond. I want to send back a pong in the return observer. So I'm just going to say response observer dot on next, and I'm going to create a pong using the nice Java builder here. And let's do some maintenance, so we'll take care of that later. And then when the client tells me that it's completed, I'm also going to close our connection here. Okay, and I'm going to do one last thing here just for the sake of having it. I want to count how many pings I get so I can see that everything's really working as expected. So I'm going to do add a little log, and I'm just going to use this here. And let's say received ping, and what I want to do is just increment every time this happens. So I'm going to create a variable called count, and let's make that here. Let's create a atomic integer, call it count, and every time we get a call here, let's increment and get. Okay, so this should log out received ping number 1, 2, 3 as we go. Okay, that's just about it. Last thing I need to do is just actually add that service to my server builder here. So let's create a new ping pong service. And we should be good to go. So now I can just run Gradle run, and I should see this project running on port 8080 if it all works out. And there we go. Okay, so it seems so far so good. The next thing I want to do is actually connect my other service to this using the same kind of pattern. I'm going to add a manifest to this project, and then we'll build the code from there. So what I have set up so far is a simple node CLI, and it just gives me a little prompt here. And what I want to happen is when I type this message in, ping, I want to get back a response from the service. I want it to send a ping message using that RPC, and then whenever it gets back pong as a message, I want to do a log here and then open up another prompt so I can keep doing that. So it's not happening yet. Actually, didn't mean to stop this guy, so let's keep him up and running. I wanted to stop this one. And let's open our node project. So first I need to pull the protos into this. So I'm going to create a proto-p manifest, and then I'm going to run the yarn install script since this is a yarn project in node. And it's going to run this for me after it's installed the rest of these dependencies. So it'll run proto-p sync, and then this -l flag means that it's also going to use the links. So I'm going to create a new file, call it protop.json. And in the interest of time, let's just go ahead and copy this since it's using the same dependencies from the service. Okay, so now I should be able to run yarn. And you see it's running the command right there, and it looks like it worked. Okay, so let's check the same directory here, and let's see if our API looks good. Yep, so this is, again, you can see this little arrow here in Visual Studio Code. This just also just means it's a symbolic link, so it seems like this is working. All right, so what I want to do is load those protos into the script now. So I need a few APIs to do that. So there's a gRPC library for Node, and that is gRPC.js. And then I also need the proto loader to actually load them initially. And that's this guy right here. And I'm going to create a little constant for the path to the protos. And I'm just going to point to the this API.proto right here. And I can just say .proto, and I'm just following this, all of this tree down here. So path, proto-p, ping pong, and then our file is api.proto. Okay, so I should be able to load these now. Let's say protoloader.load, and we're going to use the async API, which is leveraging the promise API in Node, and that just means that when I give it a protopath here, it's going to return promise, and the API looks kind of like this. And this just means that once that happens, it'll run this callback, and it gives me a function where I can pass in an argument, and let's say that that's the definition, and I can do stuff with it. And what I want to do is use the gRPC library now to actually get a meaningful object that I can create a service with. So I'm going to pass the definition in here, and I'm going to call this proto so that when that happens, I can start using this. Before I do anything else, so let's pull the rest of this code in here and make sure that nothing happens until we've loaded our protos. And I'm going to create an instance of a client now. So we'll call it client. And all I need to do is just follow the tree down. I know that the API is under protop.pingpong, so I can just follow that from the top of the tree here and just say protop pingpong. And in the JavaScript implementation of gRPC, the naming convention is just, it's not like client or stub or anything. It just is called service like that. So you're creating a client stub of the service using the name like that. And then the first argument that it needs is where the service is running. So that was on port 8080. And then it needs credentials. But in this case, we're not authenticating. So let's just pass in insecure credentials like that. Okay. And so now I should be able to create open up a stream with a server. So let's do that. Let's say that, let's call it ping pong because that's what it is. And let's just say client.pingpong pong like this. So I should be able to use this to start sending messages to the server now. So what was happening was every time I put this phrase into the console, it was just opening up a new prompt. But I actually don't want to do that. I want to send a message. And the API in JavaScript is like this. It's just pingpong.write. And we're going to pass in an empty message because there's nothing inside of those ping messages. But I'm just going to put a little note here so that we know what's happening. OK. And I also want to listen for Pong messages from the server. So the API for that is just an event listener. Say on data. And I don't need to do anything with that because that's just an empty object. But I do want to log something to the console when that happens. So I have a nifty little message, function here that's going to do that for me. And we're going to use that to just log out Pong. And we're going to have a little cartoon cow say that for us. And then I want to open up another prompt so that I can keep sending messages to the server. Also, whenever I close, whenever I try to exit the application, I want to do a little bit of maintenance. So I'm going to tell this server that we're done talking to it. And when the server is done talking with us, I also want to go ahead and just close out the prompt. So let's say on end. And we're going to close the prompt. And we'll go ahead and exit. OK, so this ideally what's going to happen now is when I type in ping, we're going to send a message to the service. And when we get data back, we're going to log it out, open up a new prompt. And let's see if it works now. So if I open up my prompt here, let's see. It didn't like my path here, so I must have done something wrong. It looks like I have a little typo, so let's fix that. And let's try this one more time. OK, it still didn't like something. Another little thing here. I need to pass this guy the new keyword. So we're creating an instance of the class. And let's give it one more shot. There we go. All right, so we have a prompt here. So fingers crossed. When I type enter, I want to see a message in the service saying that it got another ping from my client. And then I want to see a little cartoon cow saying that they got a response from the server. So here goes nothing. There we go. So the service is counting the messages that it's getting from the client. And we have our little cartoon cow talking back to us. Let's try it one more time just to see if it's incrementing and everything's happening as expected. And there we go. Our cow's happy and our service is bumping up the number as we go. So there's our example of a distributed gRPC app using Protop to share the proto packages across projects. So following up with this, what doesn't Protop do though? It doesn't, again, enforce any patterns for developing protobufs, but it does kind of suggest that you can do stuff in this way and really minimize your workflow. Doesn't fix everything or remove all the complexity. You still have to decide how to organize and architect your stack. And once you get there, hopefully leveraging tools like this to keep it as simple as you can until you just have to add things like pipelines and all that. And then it also doesn't deal with code generation. So that's kind of the biggest thing for this is it just passes the protos around and it doesn't become, it doesn't add any complication to the actual code generation part of protos. It doesn't really get involved once that happens. That's kind of the point of departure for this tool. But what does it do? It suggests simpler patterns for developing protobufs, as we've seen, and it makes it simpler and just easier to develop and collaborate on projects that use protobufs. And this doesn't matter what size your team is or what kind of resources you have. As you just saw, it was pretty easy to get up and running locally and still have a clean architecture where I have my 3 independent repositories. And I didn't have to do any copying or pasting or create a monolith. And then finally, it just focuses on that one thing, just being a decent package manager. And that's the intention there. Thank you.